I'll discuss high availability with F5 Big IP. You may configure F5 Big IP high availability in two ways. It can be active standby or active-active. With active standby mode, only one unit is active at any given time. That is, processing traffic. So in this example, traffic group 1 is active on device A only. As you can see, that's where application traffic is flowing to. Device B is acting as standby or backup for traffic group 1. So when device A fails, traffic group 1 floats to device B, and application traffic begins to flow to device B instead. When a standby unit becomes active, it normally remains active until an event occurs that requires the other unit to become active again, or until it's specifically forced into a standby state. Active standby is F5's recommended configuration. Alright, so let's take a look at the active-active mode. In this configuration, both units are in active state at the same time. Device A here is active for traffic group 1 and standby for traffic group 2. Device B is active for traffic group 2 and standby for traffic group 1. When device B fails, its traffic group floats to device A, which then starts processing that traffic in addition to its own. So, high availability happens thanks to the failover configuration. Let's take a look at the failover process. F5 provides two methods of failover: hardware and/or network failover. Let's discuss hardware failover first. It uses a direct serial cable right there. There's a connection between the two big IP systems. It can only be used for a sync failover group of two systems, no more than that, guys. So here unit 1, unit 2, and here's your serial cable connecting to each failover port. It's easier to see here in this image. So we have the failover port, and that's where the serial cable is connected. The standby Big IP system will become active in a few seconds after detecting a loss of voltage from the active partner Big IP system. Hardware failover is limited though to 50 feet. If the signal were lost due to cable failure, both units will assume active mode on any attempt to use the shared addresses and serve all the virtual server, NATs, and nets. Highly undesirable condition, guys. An active situation is not something you'd like to see, as it will likely result in traffic disruption. Network failover uses communication over the network between the pair of big IP systems. So as you can see here, they are connected. No more, the serial cable is no longer present, and they are connected using the upstream switch. Using the network failover allows the big IP systems to be installed further apart, so we no longer have the 50-foot limitation that we saw before using the failover cable, the serial failover cable, okay? Another advantage is that it allows for more than 2 members. In fact, for version 11, network failover is the default configuration. These 2 units must be configured in the same VLAN, okay? So network failover is a bit slower than hardware failover because temporary loss of connectivity across the network should not cause failover. And just like hardware failover, a loss of signal due to network failure could result in both systems assuming an active role. So like I said, network failover can be configured to have multiple pairs of partner addresses. And when it's configured that way, network signal must be lost between all pairs before network failover would be in a failed state. Lastly, let's talk about network failover with hardware failover, the two configurations combined. When network failover is enabled, failover will only happen if both the hardware cable's voltage and the network cable's pulse are lost. The serial cable takes precedence, guys. If the network failure fails, so here network failed, but if the boxes are still up, as in detecting voltage from the partner big IP, it won't fail over. You must lose both the voltage and the network connectivity in order for the standby box to take over the active role. Alright, so I hope this has been informative as well as accurate. Thank you for watching.